Section 5.2. Passing arguments to a method. Values that are sent into a method are called arguments. The data type of an argument in a method call must correspond to the variable declaration in the parentheses of the method declaration. The parameter is the variable that holds the value being passed into a method. By using parameter variables in your method declarations, you can design your own methods that accept data this way. The arguments are passed to the parameters specified in your method definition. For example, here's a method call to the showSum method. The method call passes in 18 and 82 as the arguments. These correspond to the parameters num1 and num2 in the method definition. A parameter is a variable declaration in the parentheses of the method definition. Let's make sure that the argument's data type is compatible with the parameter's data type. Well, 18 and 82 are both ints, and the parameter list specifies that the two parameters, the first one should be an int and the second one should be an int. So, yes, it looks like the argument's data type are compatible with the parameter's data type. It's just a coincidence that we're passing in two ints. We could pass in an int and a double, a double and a string, an int and another string, but we would just have to make sure that the arguments in our method call line up with the parameters in the method definition. Let's take a look at another example. Here's a call to the full name method, passing in the arguments Abraham and Lincoln. This method call is using the full name method, and if we take a look at the parameter list of the full name method, we'll see that there are two variables in the parameter list. So it looks like our call to full name passing in these two string literals, Abraham and Lincoln, is okay because those will correspond to the parameter data types in the method definition. They're both strings. So we can see that the method header in the method definition specifies a parameter list, and the data types of the arguments when the method's called must correspond to the data type specified in the parameter list. However, the real story is a little more complicated. What if we have a method, showSum, that in its definition contains two parameters in the parameter list, and they're both specified as doubles? This method returns the sum of the two parameters, and one question we can ask ourselves is, what would happen if we passed in two? To answer that question, let's take a closer look at our data types. Since chars are represented as ints, with capital A as 65, capital B as 66, and so on, we can make the claim that every char is an int. And along the same lines, every int can be represented as a float. Just add a 0.0 after it, and you'll turn, for example, an int 12 into a float 12.0. And every float can be represented as a double. After all, doubles are just a more precise way than floats to store real numbers. So everything that can be represented as a float can be represented as a double. But the relation does not go backwards. There are doubles that are too long to be floats, floats that are too fractional to be ints, and ints that are too big to be chars. A is A, but it's also the int 65, while 999,000 is an int, but it's not a character in a standard character set like ASCII and Unicode, which only go up to 256 and about 62,000 respectively. This leads to a data type hierarchy, where chars can be represented as ints can be represented as floats, and floats can be represented as doubles. But we can't go the other way around. We would lose data if we tried. However, going from char to int to float to double is possible, and these are known as widening conversions. Java automatically performs widening conversions, but trying to go the other way around, in other words, a narrowing conversion, will cause a compiler error. Therefore, we can pass an int into a method where a double was expected, but we cannot pass a double into a method where an int was expected. When arguments of the primitive data types are passed into a method, they're passed by value. That means that a copy of the argument is made, and that copy is passed into the parameter variable. This prevents the method from having access to the original argument. It'd be like if I made a copy of an important document, like a deed to a house, and passed you the copy. You couldn't affect the original document, because you've only received a copy of it. When primitive data types are sent to a method, this is how they're passed, by value, meaning a copy of them is made and sent into the method. Here's a program that demonstrates this idea. Let's take a look at it and predict the output. In the main method, number starts out as 99, and line 15 prints out number is number. We should see 99 printed out here. Then the changeMe method is called and number is passed in. Let me move over a little so we can see the line numbers. This occurs in line 19. If we go down to the changeMe method, we can see that the changeMe method prints out I'm changing the value, and then sets the parameter my value. I should have mentioned changeMe is a void method that takes in one, it has one parameter, int my value, and the method prints out I'm changing the value, and then it sets the parameter value to 0, and then it prints out now the value is, and then that parameter value which we just set to 0. So we should then see I'm changing the value, now the value is 0. That's the changeMe method, and now that the changeMe method has run in line 19. Let's go ahead and see what happens next. So in line 22, we'll print out number is number, but this is the tricky part. What will be the value of that variable number? Well, when it was passed to the changeMe method, only a copy of it was made, and that copy was affected in the changeMe method, but the original number was not affected. So we should see the we should see number is 99 again, because remember only a copy was sent to the changeMe method, so the changeMe method couldn't affect the original 99. Okay, so let's go ahead and run this program and see the output. Okay, so as we can see, the original value was 99. The changeMe method, it took an argument, set it to 0, and printed out. So we saw the 0 being printed out, but that argument that was changed was not the original. It was only a copy of the original. So when we are back in the main method and we print out number, we can see that that original value of the variable number, 99, was not affected. Before we end this section, let's take a minute to revisit an important concept from section 4.10. If a method calls another method that has a throws clause in its header, then the calling method should have the same throws clause. We saw that with the printWriter class when we passed in a string file name, and we also saw it with the scanner class when we passed in a file.